Hey guys, and welcome back to another skill in the LPIC 2 course. So what we're going to be focusing on in this skill right here is around the kernel. So let's begin by discussing what the kernel actually is then, shall we? Now the first thing to note about the kernel is that it is a modular construct, i.e. it is not one large entity that does absolutely everything. Instead, you can much more accurately conceptualize it as a core program, and this core program can actually be extended to do additional things via the use of modules, hence why it is referred to as modular. These modules can ultimately expand the kernel's capabilities. Now, the concept of modules is certainly something we will talk about within this skill. We'll learn how we can actually load modules, as well as remove particular modules we do not need, as well as listing the modules we do actually have operational. So what exactly are the type of tasks that the kernel will handle then? Well, it is involved in some very important tasks, things such as managing hard drives for your storage, or perhaps maybe your network card for network connectivity, as well as dealing with USB devices and other removable storage. So let's take the example of a USB stick. When you plug that USB into the system, of course you want that USB to be operational. Now, in order for this to happen, the kernel is going to load particular modules relating to the USB. And if you happen to remove the USB, well, the kernel no longer needs those modules, so those modules will subsequently be removed. Of course, the alternative to this would be you could have a very large and bloated kernel, which would ultimately have all possible modules loaded all of the time, but clearly this is inefficient, so this is not how we can expect the modern kernel to operate. Instead, we're going to be using that modular process by loading modules as they are needed and removing them as they are no longer needed. Now, one thing I want to talk to you about first is related to the kernel versioning number. So back in the olden days, the way this was actually numbered would be something like this. Okay, so it would be 1, 4, maybe 3, and 12. This is how you could expect to see your kernel version. Now this might just seem like a random spattering of numbers, but there actually was a very particular format going on here. So let me show you what this is. Just draw these out once again. So the very first number would actually denote the version number itself. So this would be version 1 of the kernel. The second number would be denoted as the major revision. The third number would denote releases where we had a minor revision to the kernel. And the last number right here, this would be for patch management, i.e. if we had some type of security patch that we had to fix, we could ultimately update the kernel with the latest patch, and we would denote that in this part right here. So we have the version, the major revision, the minor revision, as well as the patch number. Now eventually we worked up to kernel 2.6, and then we had some minor releases after that, like say 2.61, 2.62, you get the drift. Now before we actually reached version 2.6, there was some information baked into the numbering with respect to odd numbers and even numbers. What exactly am I talking about? Well, if we had a version before version 2.6, such as maybe 1, 5, 4 perhaps, this number right here, i.e. the second number, which would be the major revision, if that number happened to be an odd number, which it is right here, 5 is an odd number, this would let you know that this was a development release, i.e. this was not fully tested, it may not be stable. You can install it to get the latest features available, but be aware that it may actually cause your system problems and may not be quite as reliable. Now, when this was sufficiently tested and became stable, we could then have something like, say, 164. 6 would be an even number, And because we saw an even number in the major revision, we would know this was a stable release. So we should not expect any type of wonky features or major bugs. So at a glance, if I happen to show you 1, 2, 1, you would know that 2 is an even number, therefore this would be a stable release. Whereas if I happen to show you something like say 1, 7, 4, 7 happens to be an odd number, this would be a development release. Now, like I say, this continued on all the way until we hit 2.6. Now, version 2.6 was a kind of a milestone for the Linux kernel. It was very, very successful, and it happened to be used for a very, very long time. And it was actually from this point that the numbering system happened to change. So what exactly were the major changes? Well, now we would have the version, which would be 2. It would be number 6, and instead the last number would be the revision number. And every release here would be a stable release. So instead, the format would be, you would see 2, 6, 1, and then 2, 6, 2, then 3, then 4, then 5, on and on and on and on, all the way up to 2.6.39. with every single release being stable. But as you can imagine, this was eventually and gradually becoming out of hand, and the maintainers of the kernel thought, do you know what, we can't actually just keep climbing higher and higher. What are we going to do? End up with version 283 or maybe 2831? You kind of get the drift. So it was decided that the numbering had to be updated yet again. So now we flash forward and we actually get to version 3. And we have a similar format to what we saw before. Let's say 3.0.x. This is the version once again. This would be the major revision, and the X would denote any kind of minor revisions and patches. So if we happen to have some type of stability patch that had to be pushed out, it would be denoted as this last number right here. Once again though, crucially, is that all releases were aimed to be stable. There were no more attempts to push out development branches. That practice instead was ultimately deprecated. So if you happen to see a version, I don't know, maybe 3, 4, 2, it's version 3, major revision 4, and we have our second minor revision or stability patch. And this has continued on since. So in 2005, we actually had the release of version 4, again following the same format. The version, the major release, or major revision should I say, and the patch. And then in 2019, we then had our first version of version 5, again following the same format. Version, major release, and our patches. So when you happen to be looking at these kernel images, you can expect to see this particular format. Like I say, in the older versions, you may see 4 numbers. Before version 2.6, you may be able to infer a development release as opposed to a stable release, depending on if we are using odd numbers or even numbers. And then since version 3, we are following this simple format. So if I go to my terminal and I happen to type the command uname-r, this is going to show me my kernel number. So we can see here I'm using version 5. It is major revision 13. And the minor release or the patch is 0.28 generic. And if I happen to go into my boot directory, so /boot, and I do an ls, in fact, let me long list this to make it a little bit more readable, you will notice is that the initrd image has a symlink which corresponds to that actual kernel number. You see that here, 5.13.028 generic. That is exactly the kernel which I am using. Now the initrd, we actually discussed this in LPIC 1. Ultimately, it's like a very, very small kernel that allows you to access the hard disk where the main kernel actually resides. Now, what I also want to show you briefly is if we go into the lib folder and then the modules folder, I do an ls, you're actually going to see here a directory for each kernel we have on the system. So I have this one right here, 5.13.028, which is what I'm using, but I also have 5.11.027. So if I happen to go in to 5.13, and do an ls. These are all the modules and dependencies needed for the operation of my particular kernel that I'm using. See that? The name here corresponds to the folder here, and within we have the modules. So that is us for our brief introduction to the kernel. We still have a lot of information to get to, so I hope this has been informative for you, and I'd like to thank you for viewing.